Hey guys, HackerSploit here, back again with another video. Welcome back to the Web App Pentesting series. In this video, we're going to get an introduction to HTTP, because if you don't understand HTTP as a protocol, then you really don't understand what's happening on the web. So this is very, very important. So we're going to be covering how HTTP works, HTTP requests and responses, the methods, as well as the actual headers included within HTTP requests and responses. All right, so let's get started firstly by getting an introduction to HTTP. So what is HTTP? HTTP stands for the Hypertext Transfer Protocol. It is a stateless application layer protocol that's used for the transmission of resources like HTML and runs on top of TCP. That's going to be very important when we move into the practical demonstration. It was specifically designed for communication between web browsers and web servers, right? And it utilizes your typical client-server architecture for communication, whereby the browser is the client and the web server is the server, right? So again, if we just to use a simple example, a web server hosts, files or resources like HTML files. It could be, it could be JavaScript, PHP, etc. And the client is your browser. Or your client could be any other utility, maybe something like curl, right? And you make a request for a specific resource on the server, and the server responds with with the appropriate data based on your request and what you essentially asked for. And in the context of an HTML application, if you request for a particular HTML page, the actual server will take a look at the request and will identify that resource that you're looking for, and then will pass it and send it to your client, which is your browser, and that is what is displayed. So whenever you type in google.com, what's included within the HTTP request is information pertinent to your browser, and that could be your user agent, as well as other fields that we'll actually explore. And then of course the server responds to that based on what you've requested for. So yeah, that's just a basic example. Now, resources are uniquely identified with a URL or a URI. So whenever you type in, an address within your browser, it could be a domain or an address itself. That's a URL or a URI, and that is used to uniquely, identify a particular resource, right? And of course, the URI will obviously contain the resource that you're looking for specifically. So for example, a URI could be http website.com, and that could then be, redirected to the index.html page or the actual front end of the web application. It's also very important to understand that we have two versions of HTTP, HTTP 1.0 and HTTP 1.1, all right? And 1.1 is typically what is in use right now. Okay, so that's an introduction to HTTP. Now let's take a look at HTTP requests, but because remember, this utilizes a client-server architecture. So you as the browser, for example, will make a request, and this is what your HTTP request looks like. So, and more specifically, this is really the GET, or rather the HTTP method, if you will. And we'll get to that in a second, right? So clients communicate with servers via requests, and servers respond to the client's requests with responses. Data transmitted with HTTP or over HTTP can also be encrypted with TLS, and that's where you have the Hypertext Transfer Protocol secure, where the data is encrypted, and there's a lot of other security mechanisms built into that. We'll actually explore that when we get there. Now, HTTP requests are typically made up of the following. Number one, the HTTP version. So that is used to specify the version of the HTTP protocol in use. You then have your HTTP method. So you have your get method, post method, options, head, put, delete. These methods are used to specify what the client wants to do, right? And then of course you have the path, you have the actual path. This is used to specify the path of the file or document that you're trying to locate or trying to access. And then, of course, you have HTTP headers, which we'll get to in a second. So this is an example here of, for example, an HTTP request whereby you have your HTTP method. So we're saying get. And then, of course, we have the path here. So that's the file that we're trying to locate or essentially access. And you then have the HTTP version, and in most cases it's HTTP 1.1. And this information can easily be viewed through a proxy like Burp or OWASP-ZAP, or even through a tool like curl. And of course we'll be exploring this You then have your HTTP responses. Now, HTTP responses are typically made up of the following. You have your HTTP version. That's the version of the HTTP protocol being used. You then have your status code, which is very, very important, which specifies whether the request was successful. So if you requested for a resource that was indeed available, you'll get a 200 OK status code. If it's, you have 300, 400, 500, and based on those responses, you can get an idea of what went wrong really, or what, if it was successful, you'll be able to know that. And of course, we'll touch upon the status codes during the practical section. You then have HTTP headers. So I have mentioned HTTP headers in both cases, in the form of HTTP requests as well as the actual responses. So what are HTTP headers? Well, the easiest way to identify them is you can easily identify them because they have colons, right? So you have your typical key and value, and HTTP headers are used by the client and the server to specify additional information that needs to be sent with a HTTP request or a response. An HTTP request header is used in requests or HTTP requests themselves to specify information that's pertinent to the requirements of the client in order for the server to process the request correctly. So what are your HTTP headers? So this is your request here, and of course you have your method, and then of course you have the path, and you have the HTTP version. So these right here below the following first line are your HTTP headers, and you can tell them apart because they have a colon that separates the key and the value. So you have host, for example, and the host is developer.mozilla.org. Your user agent. Will learn more about what these headers are. You can see this essentially used to specify the browser, and then accept. You have accept language, accept encoding, the referrer if there is one, connection. You have upgrade insecure, so on and so forth. Now, again, for every website, web application, you're not going to see all of these headers included. They're there for reasons that I've just stated. They're there to essentially ensure that the server processes the actual request correctly or as per the requirements of the client. So an example of that would be the user agent, whereby the client is essentially saying in the form of an HTTP header that, hey, I'm using the following browser, therefore, whatever file I'm requesting, for example, home.html, I want you to render it accordingly, or to send me the appropriate response based on the browser that I'm currently using so that it's rendered correctly. That's just a simple example. You then have your HTTP response headers, right? And again, this is your typical response, 200 OK, and then, the server can also respond with specific headers. And of course, we'll be exploring this as we move along. And, you have ones like the server. That's very important. It tells you what server technology is being used. Is it Apache? Is it Nginx? Is it Microsoft IIS? And then, of course, you have your cookies. And the most important being, and I can actually find this here. I don't think it's added here. But yeah, you get the idea. So all of this will make sense once we take a look at this practically. So I'm just going to switch over to my Kali Linux VM, and we'll take a look at a few examples that will hopefully make this much more simple for you to understand, because I really don't like slides. So let me just switch over. All right, so I'm back on my Kali Linux VM, and in order to demonstrate this, and this is something that you should do as well, we can utilize what we have on hand. So I'm currently within my desktop in a folder called Web App. Now, of course, if I list out the contents of this directory, I really don't have anything in there. And what web server technology am I going to be using to host my web app? Well, I can simply just take advantage of the Python module simple HTTP server. Now, this is a great way for you to actually learn about HTTP and how it works at a very high level, and also at a packet level, because we'll take a look at how this how requests and responses look like from within Wireshark. So I'll set up the web server on port 80, right? And I'll just specify my password here really quickly. And so that's set up. And I then have, I'll open up a new tab here, and I can make a request, right? So how can I make a request? Well, number one, I can make a request with my browser. So if I wanted to access this website, and there really isn't one, so what I could do is, for example, create an index file. So index.html. Or do I actually have the default one under var HTML. I believe I do actually have a shell there. Let's get rid of that. That's not supposed to be there. That's under var HTML. Let me get rid of that. That's from a previous engagement, I believe. Looks like I can do that, so remove that. So I'll just create a simple index file here, so vim index.html, and this is just, this is just going to be a boilerplate type of thing. I can just create an h1 tag, for example. Forgive me for my bad HTML skills, so I can just call this simple web app h1. Type that in correctly and write in quit. There we are. So I'll start up the web server again with simple HTTP server, and you can also use the Python 3 module as well. So I've set that up, and if I access this via my browser, so 127.0.0.0.1, you can see simple web app, and I've essentially made a request and the server has responded. So how do we see this from the server side of things? So if we take a look at this here, it looks like we have an exception here. Let me refresh that again. And let's make the request one more time. So I'll just make the request again. There we are. So you can see that simple HTTP server will essentially display output on the server side of things. So you can see that a request was made at this specific date and time, and it is a GET request, right? And it's not requesting a particular resource really. And you have the HTTP version here. And you of course have your response code, right? Or your status code, if you will. Now, this is from a server perspective. If we wanted to take a look at the HTTP request and response in depth or in detail, we can utilize a tool like curl. So we can say curl v HTTP 127.0.0.1, right? And I can request for a particular resource, but let's start off with, just a basic request. So I'll hit enter. And you can see your request and the response, right? So your request is right over here. You have your method, which is get in this case. And if we were trying to log in, that would be a post method. And you can see I'm not really looking for a particular resource. We then have, the HTTP version. The host is localhost. The user agent. So instead of a browser, it tells the server that this guy is actually making a request with curl and the specific version of curl. And then, of course, the response is as follows. So you can see the status code is 200 OK. So that means it exists. The server is simple HTTP, the simple HTTP server 0.6, Python 2.7.18. So again, if I was doing this remotely, this would tell me, what's running on the server side of things. And of course, you then have the content type, text HTML, the content length, and these, of course, here are going to be your HTTP headers because, as you can see, they contain colons. So that's a very easy way of identifying them. And then, of course, curl renders the response here from the web server, which essentially is just some HTML code, right? So that's really how it looks like. Now, I can make a request for something that doesn't exist. So I can say, let's say resource. Let's say I'm looking for something on the web server like resource, if I can actually type it in. So resource.html. Let's see what happens here. So again, I'm making a request. There it is. I'm requesting for resource.html, and you can see the actual HTTP headers here that we obtained previously. And for the response, we now get a very different response in that the actual status code is set to 404, which means not found, but the rest of it is the same. And of course, you can see, the amount of HTTP headers here are not really as many as you saw within the slides. And that's because this is a simple web application. So you're starting to learn, or you're starting to get an idea of what's happening here. As I've said, I've broken the actual request down so that you can understand it. This is your method. This is the path to the resource, and this is the HTTP version. The rest over here are all HTTP headers. Now I'll explain these in a few seconds, right? Before we continue, I'd like to take a few minutes to thank our sponsor for this video, Integrity. Bug bounty hunting is a rapidly growing field within cybersecurity and is a great way for independent security researchers like yourself to showcase your skills and earn money for your hard work. Choosing the right bug bounty platform can be quite confusing given the plethora of choices available. This is where Integrity comes into play. Integrity is Europe's largest bug bounty platform with over 40,000 active security researchers and more than 200 active programs to hack on. So why should you consider using Integrity as your bug bounty platform of choice? Integrity has a huge focus on community enablement and offers various resources to researchers for free, like their weekly Bug Bites newsletter, monthly cross-site scripting challenges, weekly YouTube videos featuring new tools and hacking techniques, fantastic resources on how to write bug bounty reports, and offers a blazing fast triage that will reproduce every report within the first 24 hours after submission. To begin your bug bounty hunting journey with Integrity, use the following link to get started. That is go.integrity.com/HackerSploit. And of course, that's your GET request, and you have your response here, and you can go through it and get an understanding of how that works. Now let's take a look at what's happening from a TCP level, right? So I'll open up Wireshark, and we'll give this a couple of seconds. I'll just open this on any here. There we are. And what I'll do is I'll make another request, this time not for something that doesn't exist. So I'll just say curl and specify the address there, hit enter. Let's open up Wireshark. So we have a few things going on here. Remember, I told you that HTTP runs on top of TCP. So you'll obviously see your SYN, SYN-ACK, and then ACK, which is exactly what we see here. So you have your source and destination. I wish I could have set up the web server on another system so you could see that the source and destination is different. But you have your SYN, SYN-ACK, and then of course ACK. So, that is successful. The TCP three-way handshake is successful. And then the GET request is made right over here. So if you click on the GET request itself, you can see that you have your various pieces of information pertinent to that packet. So you have your, because I'm on Ethernet, I have my frame. And then, of course, we have IP, so that's Internet Protocol. If you're familiar with the OSI model, you know what's going on here. You then have TCP, and HTTP falls under application layer. So if you click on HTTP, the Hypertext Transfer Protocol, you can actually see the request. And then you can look for and identify the actual response, right? So if we click on HTTP there, that's the response from the web server. You can see what the actual web server responded with. So I just wanted to again highlight at a very high level what's going on when you actually make a request. And not many people actually know or consider TCP, right? Because in order for there to be successful communication, there needs to be a protocol that facilitates that. And obviously, unless you're working on UDP, that's going to be TCP, and TCP has a handshake. And in order for that handshake to be completed, there has to be, an actual, handshake process, which I've already covered. So I'll not go over that right now. But you can see what's happening, at a TCP level as well. You have your source port, destination port, the sequence number that's pertinent to the handshake process itself. So SYN-ACK, you can see that here. And you have the acknowledgement number there, and you can go through that information as well. And of course, you have your final ACK that confirms, the actual handshake process, and it essentially gives a go-ahead for the GET request to be made via HTTP. Okay, so that is at a very high level what's going on in the background. And of course, I've touched upon the HTTP requests and responses. I've touched upon, the various methods, as well as what's included within a request and a response. And then, of course, we have the headers. So let me try and make a request here to probably another web application. I'm just trying to identify one here. Now, in order to intercept these requests, we can use a proxy. And that's where burp comes into play. So you're now starting to understand where burp falls into play here, right? So it's used to intercept traffic or requests that have been sent, and then you can modify requests, and you can then send them to the server and see how the server responds. So that's really what burp is used for at a very high level. As I said, it can do much more than that. So let me just open up burp here, and we'll take a look at a few other websites. So I'm just going to wait for it to pop up. All right, so apologies for that, guys. It looks like Burp Suite has crashed on me, and it seems to be an issue with my version of Java, but I'll get that fixed. Kali is not failing on me yet. So I'm going to be using OWASP Zap, and again, the main objective here is I want to go over a few things more specifically, and that of course is the HTTP methods as well as the actual HTTP headers, right? And the only way to demonstrate this really is to probably try and log into one of these sites. So I'll try and access Twitter here, for example, right? And what I'll do is we'll actually wait for that to start up, and we'll click on request here. And where is that? That's where it is. So continue to my target, and let's say we want to sign in, and then I'll put a break on this here. So yeah, let's put a break on that there, and we can just enter a test email. So, test@test.com, and let's take a look at that request. Okay, so let's see. Let's take a look at, let's take a closer look at this request, right? So you can see that now we have the HTTP, we have a different HTTP method because we're not requesting, we're actually sending data. So what data are we sending? Well, we're essentially sending the email, right? That's really the only piece of information that's being sent here. So the post request is used to send data to the web server. And in the case of a typical, LAMP application, the data will probably be stored or will actually be cross-referenced with an existing entry within the database. But if it's not logging in and we're simply sending we're trying to upload a file, then that file is stored on the server. Or if it's data that's being stored in a database, it gets stored in the database, right? And then you have your various HTTP headers. Now, if we take a look at the actual request here, you can see that that's the actual path to the resource. So, api.twitter.com, HTTP version is specified. This is the actual path to the resource. And then you have the HTTP version 1.1. The host is essentially, the actual server that you're trying to reach out to. And then you have your user agent. The user agent is essentially the browser that's making the request. And I've already mentioned why this is very important, because it essentially helps the server, or in this case Twitter, provide us with a properly rendered version of Twitter that will work on my browser and my device. Because I could be accessing it from a mobile device, and in that case it needs to send a responsive version of the web page. All right, so that's just the top level stuff. Now let's take a look at some of the more interesting ones here. The next one that I want to highlight or cover is the HTTP header. Let's see if it's actually here. There we are, content length. All right, so what is content length used for? Well, it's essentially used, so in this case, we're sending data to a server, right? So it's essentially used to specify how much data is being sent over, so that the web server can essentially ensure that it's not missed out on anything, and it's received the entire amount of content. We then have the other one that I wanted to cover was let's see if I can find it here. No, we'll actually get into these ones here later on because they're not really important right now. Probably the one that I wanted to cover here is, I can actually see it within this particular request, but that's fine, I guess. We also have the cookie that essentially contains your cookie information, and you can also see additional trackers like guest ID, marketing, so on and so forth. That'll make sense as we progress. And yeah, so I just wanted to highlight a few of these headers. Again, it may be a bit confusing right now, but hopefully I'll be able to help you understand what's going on, because when you're dealing with complex web applications like Twitter, for example, some of this can be quite confusing. All right, so again, what I'll be trying to do is I'll be explaining the rest of the headers, both in the case of a request and a response as we move along, but I wanted to cover the response headers here. So let me just head back into the browser, and it looks like we have a good response here. So at the top you can see HTTP version 1.1, 200 OK, and the content type is application JSON, and a few other headers that we can explore here is probably the server, which is it displaying that here? I don't think so. That's one that I wanted to highlight, but as I said, we'll get there when we get there. But for now, all I want you to do is, again, just use the actual simple HTTP web server to start learning how to analyze how to analyze requests and responses, and understand the various HTTP headers as well as the methods and the status codes, because that's the most important thing. So this is just an introduction to HTTP at a very high level. As I said, we'll be exploring more about HTTP, more specifically HTTP cookies and sessions, and the headers will start making sense as we progress. All right, so this is where I'm going to end this video here. Let me know what you guys think, what else you want me to cover. If you have any questions or suggestions, please let me know in the comment section. If you want to reach out to me, you can do so via Twitter or via the HackerSploit Discord server. The links to both of those platforms are in the description section, and I'll be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.